right, guys, welcome back to another episode of Madibo Hacks. Today, we're going to continue with the second part of how to deploy high availability version 3 in Azure Cloud. Okay, now it's been some time since I did the first part, around 2-3 weeks. I don't recall exactly, but it doesn't matter because it was intended to be this way. Like the first part, last video, was about configuring high availability from the provider perspective. Now, in this second video, we're going to deploy high availability not from the Azure provider perspective, but in the CSR perspective. All right. Now, in order to start, let me share my screen so you can see the terminal. And of course, I will use this guy, which I found in Google. You just type in configure high availability version 3 in Azure. That's it. All right. One of those should have the same documentation I'm using, and don't worry, I'm going to paste the link in the video as well so you don't get lost. Now, so the first step is to build an IPsec tunnel. What's that for? Because we want a ERGRP neighborship. You can do it also with PGP between the two CSRs, and that's because at some point we're going to configure bidirectional flow detection alias BFD. And BFD is going to help us to, once a router goes down, once a CSR goes down, a notification from BFD, neighborship going down, is going to be sent to the Azure portal so that we can trigger the next hub change. All right. Now let's start with this. So we need to configure an IPsec tunnel. I'm going to follow this. We could also, copy and paste this. Actually, I can do it for this part, I think. And I know because I've done it in the past. So let me go to global configuration mode, and I'm just going to paste this. That's cool. Done. Now the second part. This was to create the ISA KMP policy. And the next step is to configure the transform set. I can also copy and paste this as well. I'm not an IPsec engineer. I'm not going to go deep within this configuration. And this is not the purpose of this video. The purpose of the video, is just to configure high availability. And by the way, this IPsec profile BTI-1 is the same. We can just copy and paste this. Okay, I'm going to click exit, Command V, done. Let me go back to global config mode, and the next step is the tunnel interface. Now, we have 3 interfaces. Okay, we have 3 interfaces, and we're going to use one of them for the purpose of the tunnel. And in this particular case, I think we're going to use the Gigabit Ethernet 3. If I'm not mistaken, that interface, the Gigabit Ethernet 3, was the one we intended to use to build the tunnel. So let's do it. So I'm going to change the source. It's not going to be the tunnel source Gigabit 1. It's going to be the 3. Tunnel mode, IPsec IPv4, okay, that's good. The tunnel destination, I'm going to use, the guide uses the public IP address, and I'm going to use the private IP address, so hope we don't get any issue. Okay, so we're going to use the 10.6.204. Tunnel protection IPsec profile BTI-1 -1, BFD interval 500, min Rx 533. Okay, seems legit. So I'm going to copy this now that I have edited it in Sublime, and let me paste that. Dang, I exit global config mode. Never mind. Done. Now let's go to the second. Let's go and configure the second CSR. Now the SSH timeout already expired, so I need to wait a little bit in order to access it back again. Not yet. Not yet. Okay. I can access it one more time. Good. So let us do the same for this one. So I'm going to copy the ISA KMP policy, the transform set, the BTY-1, and that's it. I'm going to copy and paste that all the, to save us some time. Okay. Most likely I got this message because I already configured it in the past, but they shouldn't cause any trouble. Now the tunnel, we already used the 1 for the 4th octet, so I'm going to use the number 2. Load interval. The tunnel source is going to be as well the gigabit Ethernet 3 because it belongs to the same network. Yes, it. All right. Tunnel mode, like we said 4. Tunnel destination, this is going to be 5 instead of 4. Tunnel protection, BFD. All right, done. So let me copy and paste the tunnel. I'm already in global config mode. Done. All right. Now let's see what's going on with our tunnel. Okay, so that seems to be all. So that's good. Let's try to ping the neighbor tunnel interface. Okay, so that's good. I can ping neighbor. Now, I already have a tunnel. The next step is to create the ERGRP neighborship, and inside the ERGRP routing protocol, place the BFD feature. Now, let's go to global config mode in both sides. I'm going to start with right hand. I'm going to use autonomous system number 1, network 192.168.1.0.1.0. I'm going to use sorry, the wildcard 3. And that's it. Let me do the same on the other side. Let me configure ERGRP. ERGRP1, network 192.168.101. 101, I like to say that. Okay, done. So hopefully if I do show IP ERGRP neighbors, I should see something there. Okay, so that's good, I can see that we have an ERGRP neighborship. Now, I also need to configure BFD inside router ERGRP1, router ERGRP1, and let me do BFD interface, and let me specify a tunnel. Tunnel 1, BFD interface tunnel 1 as well, and hopefully I'm going to see a BFD neighborship established as well. Good, and it's up. Okay, so that's perfect. That's perfect. Okay, so now the next step would be to move into Gasho, into the Linux container that we call Gasho, and configure the parameters we need. So once the neighborship between the two CSR fails, we are able to send, if I'm not mistaken, a REST notification to the Azure provider so we can change the next hub IP address, all right? So let's do it. Let's do it. So I'm going to hit get shell, and I think already enabled. By default, is not enabled. You have to hit get shell enable in privilege exec mode, okay? Okay, so we're here. And now I'm going to go to the guide. And if I scroll up, I'm going to see that this document is built not only for Azure, but for AWS and also for Azure and Google Cloud Platform. Okay. Let's see. High availability in Microsoft Azure. Okay. So I need to go to the get shell part of the guide. Okay, here. Here. Okay. Oops, I'm almost out of battery, but thankfully I didn't notice that. I think this is kind of old. Not sure if this will work. Let me go back. So it should be here. Okay. Yes, I think this is it. This is it. Okay. Redundancy topologies. Okay, so now the first part is once we are in the guest shell, we need to install a package of the high availability feature. Okay. So this is it. This is it. I need to install this. So it will be this, if I'm not mistaken, right? So let's try to execute this. And I think that in the current version I'm using, I do not have PIP, but I have PIP3. So let's try and hit this. Okay. Let me include this dash user, that dash user. No. Okay, it doesn't matter because I have this already documented. So any guide you look needs to have following. CSR. So it should be this command, nothing more. And okay, so that looks good. Let's execute that as well here. Fail. Okay, so right hand is fail. Okay, I need to use the user. Okay, as you can see, successfully installed CSR Azure HA-310, the same at the left hand. So that's good. Now we can start building our nodes. Our nodes. Yes, sir, our nodes. So let me move here. Yes, As you can see, the next step, once we have installed the CSR Azure High Availability package inside gas shell, then we need to configure the redundancy nodes. And here in this table, we can see all the parameters we have. Okay, so let us see an example and create an example based on that. So let me copy this. I'm going to minimize my screen as well so I can bring my text editor. Okay, here we go. All right. All right. So, okay, let me create another tab. Done. Okay. And here we go. Okay, here. So the first parameter we have here indicates the index that we're going to use to identify a node. In this case, I'm going to leave it as 10. That's okay. I will not have a problem with that. Then we have -p, which stands the cloud provider. In this case, I'm going to use Azure. Now, the -s indicates the Azure subscription ID. And for that, I need to change that because my subscription ID is unique. So let me go here and in any CSR, in any object I have inside Azure, I'm going to see always my subscription ID. That's okay. So I'm placing my subscription and -g. Let's see what does -g mean. So that's the resource group. The resource group. And that contains the route table. Okay, so we need to go and I'm going to do this search for the resource group of my routing table. So we should see it here. So I already copied that and I'm going to paste it. Okay. Okay, that's it. And let's move to the -t, which indicates the name of the route table to be updated. So what's the name of my routing table? It's private routing table. So let me copy this and let me paste it. And we have also other parameters, such as the route. The route is unspecified, then the redundancy signal is considered to apply to all routes in the routing table. Okay, so let's do that. I don't see any reason why we need to configure a specific, right? Since this is just like a test for you to see. But you can specify any route you would like. Okay. So done. Let's just copy this and paste it. Okay. So I got an error. The following arguments are required, -n. So it seems that we missed a -n. -n, next hop address. Okay. Okay. So let's go. If I check the routing table here, if I check the routes, I'll see that my next hop IP address is the 10.6.104, which, if I'm not mistaken, belongs to one of the subnets here. Okay, never mind. So, So if I need to specify the next hop as then my neighbor router, right? This let's say that will leave the next hop IP address of my neighboring router. So that's 10.6.10.04. Let's see it on the left side here. And if not, it doesn't matter. I can scroll up, you know. Okay, yeah, so this one has the 5. Okay, so I'm going to place 5 here. But let me verify because use the IP address that is assigned to the CSR 1000B on the subnet, which utilizes this route table. Okay, so I need to use my own. So in this case, it will be 4. And in the left hand, it will be 5. So let me log in. I'm not sure why I'm getting that error. If someone knows, please help me with that. Okay. Okay, but well, as you can see, I already created. And I'm going to copy and paste this in my text editor. But now I'm going to use the one I have here. Okay, I'm not sure what I'm getting that. Just bringing. Okay. Why? Why? Let me read all the terminals. Open them again. And this is common, right? With playing with this kind of setups, we always get this kind of unexpected little issues. And okay, so I'm back. Um, Thanks. I need to go back to Azure. This is 1. Let me go to 2. Let's hit connect SSH. Copy this. Let me place a M key. Okay, back in business. And you're asking perhaps how do I found the node? So I can use show node.py and as the parameter specify all. And okay, so this one was the one where we configured the first node. And if I execute the same at the right side, you will see that I do not have any. I have nothing. Okay, so I typed show node. Okay, there's nothing there, all right? So let me configure that. Okay. All right. Perfect. So it seems that I successfully created a new node. And if I click there, you know, you see that everything is almost the same, right? The index, the cloud provider, the subscription ID, obviously the resource group, the routing table, but the only thing that's changing is the next hub. So from my perspective, I think everything seems to be okay. So what will be the next step? Well, obviously, we need to test it. So let's try, let's review the BFD neighborship. It's up. Let's go to the tunnel and shut it down. Now let me go to home and to the route tables, and let's see if this route table is actually changed. Let's go to routes. Okay. And we have just one route here, so that should change. So let's do it. The current next hop is 4. So this is the one. 10, 6, and 4. Okay, so let's shut the tunnel here. Interface tunnel 1. Let's shut it down. Now, if I shut that tunnel, the BFD neighborship fails. We also do not have any neighborships with ERGRP. And if that happens, our next hop should change, which seems to be not the case. But it doesn't matter, like we need to troubleshoot. Okay guys, so I don't want to make this video any longer. From my perspective, we have configured everything. So I'm going to make a third video, and that's going to be for troubleshooting the deployment of high availability. All right, guys, thanks a lot for watching, and see you in the next video.